started. Hello guys, this is CodeNCode and this is 7th lecture of Java Design Patterns series. In this lecture, we are going to learn one of the structural design patterns, that is your proxy pattern. So in this lecture, we will cover what is the proxy pattern, what situations you may apply proxy patterns, how do you implement it, and what are the benefits of applying proxy pattern in your design, right? Everything. So let's get started. Let's start with the definition of proxy pattern. So the proxy pattern is structural design pattern that provides a surrogate or a placeholder for another object to control access to it, right? So basically another abstraction layer in between the actual object and the client, right? So it is used when you want to add an extra layer of control over how and when the object is accessed or manipulated, right? So now the proxy acts as an intermediary between the client and the real object, right? So you write another class that is proxy. So instead of directly interacting with the real object, the client interacts with the proxy, and the proxy interacts with the actual object, right? So the proxy acts as an intermediary between the client and the real object, allowing the proxy to perform additional tasks before or after the request reaches the real object. Like if you want to log something, right? So a client wants to perform certain wants to call certain functions, right, from the real object. So you add a proxy at each time that function is called. Before or after, you can log certain messages, right? Like the transaction begins, you can call the transaction function, then at the end of it you can write another log, transaction completed, something like that, right? So if you want to add some extra layer of functionality, you can add proxy pattern there. And there are different kinds of proxy patterns. For example, virtual proxy, right? So it delays the creation and initialization of an expensive object until they are actually needed. And it is a very famous term, that is lazy loading or lazy initialization. That means you can have an object and you will initialize it if and only if the object is actually needed, right? So in that case, this process is known as lazy loading, and you can implement lazy loading or lazy initialization using virtual proxy, right? Again, proxy pattern comes up here as a help. Don't worry, I will implement this as well, right? Then we have remote proxy. So represent an object that is in a different address space, like remote server or something, right? It handles the communication between the client and the remote object. So this is your remote proxy. Then we have smart proxy. So adds additional behavior when the real object is accessed, such as logging, caching, or reference counting, right? So smart proxy is basically when you want to add some extra additional tasks, right, each time the object is accessed. For example, caching, right? We'll actually implement smart proxy also. So don't worry about it. We'll see the implementation and the things will be much more clear. And then we have protection proxy. Of course, as simple as this, it controls access to the real object based on the right permission or access rights or permission. So basically, let's say you have banking app and so some person wants to perform certain actions. So you can add a protection proxy class. So each time where they want to perform certain transaction on the using the real object, protection proxy class will check whether they have correct permission or not, whether they are user or they are admin. If they are user, it won't let the request pass to the actual object, and it would direct return from there, or you can throw some exception from there, that not correct permission or something like not right user, something like that. It's up to you, right? And if it is admin, it will let pass the request, and it will actually call that transaction function on the actual object, right? So this way you can implement protection proxy. So we have four different types of proxies: virtual, remote, smart, and protection proxy. So we are going to implement most of it, like I think 3 of it, right? And so give you some idea that how proxies work. How do you implement it? Very easy. Let's say you have a certain interface like bank account, which has three operations, three functions: deposit, withdraw, and get balance, right? You have an actual class that implements it and provides the functionality, right, which is real bank account. So it implements bank account and of course provides implementation of all three functions: deposit, withdraw, and get balance. And it also has field balance, right? It keeps track of a balance of a account holder, right? Now the client wants to direct interact with the real bank account, but we don't want that, right? So what we'll do, we'll create a proxy bank account. So let's say you wanted to implement certain protection proxy. Basically you wanted to apply certain protection, right? You wanted to apply some certain checks for the authentication and authorization. So what you do, you create a proxy bank account. Basically this is the proxy, and it would have it would implement the same function, sorry, it would implement the same interface as the original object, right? So that's why in the client, that is in the main class, when you want to create an object, you can simply say bank account is equals to new proxy bank account, right? So instead of initializing bank account with a real bank account, you're initializing it with the proxy. And since both of them are implementing same interface, they both are providing the same functions, right? But in the proxy, you would add some certain extra functionalities. For example, you see here check access function and log operation function, right? These two functionalities are not provided by the real object or real class, but your proxy, you can, in your proxy you can add extra steps, add extra tasks, right? You can do that. And that's why this proxy bank account has provided two extra functions to check whether the user has the access to perform this action or not. If it has, then it will call the function from the real object. So how proxy works is that you create a proxy and then it would implement the same interface as the real object. It would provide implementation of all of those. Basically in all of these functions, it calls all of the function from the real object using the real object. So the proxy has the reference to the real object. You see here, real bank account is of type real bank account, which is this, right? It also has initial balance like the real bank account, and it also holds the user role, whether it is user, whether it is admin, things like that. So you can define proxy and that proxy will actually hold the real bank account or real object in itself, right? Now this is how you implement proxy design pattern. Very easy, very simple. All you do is just create a proxy class and it will have reference to the original class object, and each time a client wants to access certain functions, it would do it through the proxy because proxy provides the same functions, right? So this way you can implement proxy design pattern. And let's take a look at the implementation so the things are much more clear. All right, so let's see how you implement proxy pattern. So let's take a look at the implementation of proxy design pattern. So let's start with the smart proxy. Okay, so the smart proxy is when you want to access an actual object, you can add a proxy in between to add some extra tasks, right? Like caching, logging, things like that, right? So let's say we have an interface which is math service, which provides the function compute factorial, right? So what it would do, as the name suggests, it would compute the factorial and return the factorial. Simple as that. So this is the real math service, the actual object. So what it does, it implements the math service, and what it does, it just calculates the factorial and returns it, right? It prints the message finally that this is the result of the factorial and returns the result. And if yeah, clearly if the number is less than 0, it returns, it throws an exception that the number should be non-negative, right? So this is the implementation, this is the real object, and this is my client. This wants to have this real math service to compute sorry, to compute the factorials. But the thing is that we want to provide certain extra functionality. For example, here you see in the smart proxy, I am calling compute factorial with the same number twice or more than that, right? So if our implementation had the functionality of caching, it would perform much better, right? So I want to add an extra functionality of caching, but I don't want to mess with the original object, है ना? It has certain business logic and I don't want to mess with it, right? So what I'll do, I'll create a separate smart math service proxy, right? So in this service, in this proxy, I can add extra functionality if I want to, right? So what I'm doing here, I'll have real math service here, and along with that I am creating a cache, right, which is nothing but a map from integer to long, which will basically hold the factorial of a certain number, right? So this is the constructor of smart proxy. All it does, it initializes the math service and initializes the cache, right? Once you're done, it if using this, since this also implements the same interface, right, it would also provide the compute factorial. Now since you have implemented caching, before going to actually calculate the result, what you will do, you will check in the cache whether this number exists or not. If the cache has this number, that means you already have calculated factorial of this number, so you can directly return the result without calculating it, right? So you are returning from here the result, as simple as that, right? And since you are returning the result directly from here, it won't log that computed factorial, it won't log that, right? It would log that returning cached result, as simple as that. If it doesn't have the result of this number, the factorial of this number, what you will do, you will now call the actual function from the actual object, right? So real math service dot compute factorial, you'll get the result, you'll put it in the cache and return the result, as simple as that. So you see, we didn't make the code dirtier for the actual service, right? This is separation of concern, right? I want to add cache to this, and again sorry, again having a cache or implementing a cache is not a concern of math service. It should only concern itself with the math related stuff, right? If I want to add extra functionalities, I can write a proxy, have an object there, and define functionality, extra functionalities here, which is the caching mechanism. I did this here. Each time someone tries to access the compute factorial function, I'll check whether it already exists, return it from here. If not, I'll calculate using the real service, right? And then save the result in the cache and return it, as simple as that. So if you take a look at the demo, what we are doing, we are creating an object of math service. You see, math service is the interface, and since a smart proxy also implements the same interface, so you can initialize this interface using this object, right? As simple as that. So we're initializing it with a math service proxy, and we can call the function compute factorial because smart math proxy implements that interface. So now what I'm doing, I'm simply printing that first call, second call, third call, right, to keep track how many this is the first call or the second or third. Each time we may or may not pass the same number. For example, first and second call are passing the same number, so this will show us the functionality of caching. So first call, we are calling the factorial of number 5, and then we are printing the result. Second call, doing the same thing. Third call, calculating factorial of 10, right? So if you see, first call computed factorial of 5, which is 120, and got the result. So it says computed because first time when we are calling factorial of 5, it doesn't exist in the cache, that's why we have to calculate it. Now in the second call, if you see here, returning cached result. Second time when you call the same function, you don't have to change anything, right? Proxy will take care of it. You call the same function, got the result from the cache, and you didn't call the actual service, right? And in the third case, of course, we are trying to get the result of 10, which doesn't exist in the cache, so we'll calculate it. That's why computed factorial and return the result. So you see, you have implemented smart proxy and added functionality of cache in your code, right? So this way you can implement a proxy, as simple as that. Just define a proxy class, implement the same interface as the original object, right? Have original object inside of it, so each time when that function is called from the interface, right, you can call the same function using the real service, but around it you can add extra functionality. For example, before and after calling you want to log something. What you can do, before calling the function, here you can log something, just after this you can log something. So anytime you want to add some extra functionality, you can actually create the proxy classes and implement the proxy design patterns, right? All of this code I have uploaded on the GitHub, on GitHub repository, link of which I'll provide in the description of this lecture, right? And there are other proxies I have implemented as well, like production proxy, virtual proxy. This is used for lazy loading, right? So all of it, I'll of course you can check it out on the GitHub repository. Yeah? I'll provide the link of the repository in the description of this video, right? So yeah, this is it for this lecture. Thank you guys for watching. Until the next video drops, keep coding. Thank you.